This is Pre-Calculus, Section 2.4 Notes, Day 1. Today we're going to explore the transformations of the functions a little bit further. So we're just going to use this graph of, what looks like a parabola, and we're going to talk about the different transformations that we can make with these. So the first thing we're going to talk about is a vertical shift, a shift up. So this would look like if we had y equals f of x plus some k value. We usually use k to represent a vertical shift up. And I'm going to color code this here. So if we were going to be shifting up, then our graph would just look like this. Okay. Then if we were going to shift down, we would have y equals f of x, and then this would be a negative value for our k value, and then it would do this to our graph. Horizontal is going to either shift our graphs left or shift our graphs right. So I'm going to actually start with the left-hand shift here, keep with the blue. So this is going to look like y equals f of x plus h. Now these horizontal shifts are always confusing because they are opposite of what you would expect. So I'm going to put a little note here. Horizontal shifts seem opposite. It's because the equation is f of x minus the value of h. So if h is -3, then it becomes f of x plus 3 in the equation. Okay, so a shift left 3 would just make this graph look like this. And if we were going to do a shift to the right, and this would be if h equals +3. So that would look like that. So those are our vertical shifts and our horizontal shifts. Next, we're going to talk about reflecting a graph over the x-axis. So basically, an x-axis reflection just looks like the opposite of the original function. So if we had a negative sign in front of it, that just basically is a reflection over our x-axis. So we would have the same thing that we have here, but we would have it reflected over our x-axis. Reflecting the graph over the y-axis, the negative sign is inside the function with the variable. So this is going to look like this. F of -x, and that's going to be a y-axis reflection. So that is going to look something like that if it were to be reflected over the y-axis. The next thing we have to talk about is our vertical stretches and our vertical shrinks. That we're used to this being our A value. So I want you to remember that if we have a vertical stretch, this is going to spread our graph out. So we're going to say this spreads our graph here. So this is going to look like y equals A times f of x. So our graph is going to have a vertical stretch or a spread only if our A value is greater than 1. Okay, and it's going to stretch our graph by a factor of A. Okay, it's going to stretch our graph out by a factor of A. So whatever A is, it's going to make it, it's going to do that to it. So perhaps we say that A is 2. So our graph would look something like that if we had a vertical stretch. And sorry, I changed it to A. This is A equals 2. Now a vertical shrink, go ahead and change my color here. A vertical shrink is going to look the same, the equation is, because you're going to have some a value in front of your function. But what's going to be different here is that your a value is going to be a number between 0 and 1. And so this is what is going to cause your graph to shrink by a factor of a. Okay. So in this case, our graph would look something like that if we were showing a shrink by a factor of 1/2. Horizontal stretching and shrinking is going to spread your graph out, okay, or smush your graph together, depending. So let's talk first about the stretching things out. So a stretch is going to spread things here. And it's going to look like this. Y equals f of, and I'm going to use C for this one, C times x. And this is, again, it's opposite of what you would expect. So this is when C is between 0 and 1. This is the most confusing one to remember because you're going to have a stretch by a factor of 1/c, okay? It's going to spread your graph out. So for this one, basically it's going to make everything twice as wide. The height isn't going to change. The width of your graph is going to change. So that's going to make it, sorry, that got a little sloppy there. That's going to make it look like that. And then we can also have a horizontal shrink, or I like to call it a horizontal smush. Because it's smushing your graph together. So this is going to look like y equals f of, again, c times x, but this time c is a number greater than 1. And this is going to shrink your graph by a factor of 1/c. Okay. So for this one, it's basically the graph's going to happen in half of what it would normally have happened in. So it's going to be like that instead. Okay, so you can kind of see the difference. Sorry, you can kind of see the difference there between a spread and a smush, or a stretch and a shrink, vertically and horizontally. So now let's kind of apply what we just talked about and try to say what we see here in these equations. It says describe how the function can be obtained from the graph of f of x. So you don't have a graph, you just have the written form of the function. So if we have y equals f of x and then we have this -9 after, then hopefully you're recalling that that's going to be a k value right here. So we are going to shift down 9. It's going to be a vertical shift. That 3 out in the front, that's going to be an a value. So we are going to multiply our y values by 3. Or in other words, this is going to be a vertical stretch. It's going to make our graph longer from top to bottom. Number 3, we have two things going on. Okay, that negative sign out in front of the graph is a reflection over the x-axis. And then that +5 inside is a horizontal shift. Now, with transformations, order matters. It's kind of like PEMDAS. You have to start on the inside and you have to work our way out. So technically on this one, you would shift left 5 first. Okay, so that's a horizontal shift. And then after you did your shift, you would reflect over the x-axis. That negative sign in front is a reflection. And then the last one, this one is the tricky one. So this one we've got y equals f of x over 4, or you can think of this as f of 1/4 times x. Either way, it might be easier to think of it as x over 4, but you're going to do the opposite of what you would expect. So you are actually going to multiply your x values by 4. So this is going to be the horizontal stretch. And again, that's the trickiest one, and we'll talk about that one, and we'll do a couple examples of that together. Okay, so for our last thing here, we've got a graph of some function f of x is given, and they want us to sketch the graph of each of the following. So this is where having a couple different colors really comes in handy here. So I'll do my first one in green. That +3 is just going to be a vertical shift up 3. That +3 is a k value. So I'm just going to take each of my points on the graph, kind of key points here, and I'm going to move them up 3 units. Okay, so that's what number 1 would look like there. And number 2 here, that f of x minus 1, that's going to be a horizontal shift. That's an h value. And again, it's opposite of what you'd see. So you think it's 1 to the left? Nope, it is 1 to the right. So we're just going to move each key point 1 unit to the right. And then our final transformation here, that negative sign in front of the f of x, that tells us that we are going to be reflecting this graph over the x-axis. So you just take your point and you do the mirrored image of it over the x-axis. So there we go. So we have successfully done our 3 transformations.